So here we have CPM Calculus Chapter 2, number 40. So we want to write an expression in some summation notation that will approximate the area of our function between 3 and 7 using 8 rectangles. So we have to specify if we use left, right, or midpoint rectangles. Then enter our summation expression into our graphing calculator and evaluate the approximate area. So let's start off by looking at, let's say left endpoint. So remember, if we're looking between 3 and 7, so 3 and 7, right now I don't even care what our function looks like. So let's say it looks like this. Okay, and I want to use 8 rectangles. That means I need to split this region up into this region right here into 8 different sections. So I know that if I split it up into 2, this is going to be 5. If I split this then into 2, this is 4, and this one into 2, it's 6. So to make this 8, I need to go to 3.5, 4.5, 5.5, 6.5. So if I do that, it's kind of hard to see, but I'm going to have 8 rectangles. If I split it up from 3, 3.5, 4, 4.5, and so on, I'm going to have 8 rectangles. 1, 2, 3, 4, 5, 6, 7, 8. Yes. Okay, I didn't really draw the scale. I just want to give you an overall idea. So using the left endpoint, so each rectangle, let's just look at the first one. Each rectangle can be created using any point as the height. So the left endpoint is going to use the left point as the height of the rectangle. So if we're going to approximate the area, A of F starting 3 to x to 7, we know it's approximately, again it's not exactly equal because we're approximating, it's going to equal to, well, what's the base? Remember the base is from 3 to 3.5, so it's 1/2. And then if we use our summation notation for the height, so the 1/2 can go in front or in back. But basically, if you remember from earlier problems, we want to go from I equals to 0 to 7 because we have 8 rectangles. We go from 0 to 7. And then we have our function, and where do we start? We start at 3, so we use 3 plus, and each time we want to add 1/2 because we want to go from 3 to 3.5, 3.5 to 4, so we want to add 1/2 times I each time, right? So if we plug this into our calculator, so how do we plug this into our calculator? We can write it basically our summation notation. We could put the 1/2, we can move it inside, so we can put 1/2. If we look at our function here, is 2 times x plus 4 over x plus 6. So 1/2 times, and then we write our function, 2 x plus 4. So x is our 3 plus 1/2 I. 3 plus 1/2 I. And we add 4 divided by x plus 6. So x again is the 3 plus 1/2 I plus 6. Okay, so that is our expression. Our variable here we're using I. We want to start at, where do we want to start at? 0 and stop at 7. So 0, stop at 7. So if we plug that into our calculator, we're going to get approximately, I'm going to round to 3 digits, 6.494. And remember the units, since we're not told what units, like meters or feet, we just write units, units squared, because we're multiplying across base and height for every rectangle, so we get units squared. Okay, and again, this is using our left endpoints. So let's just look at every okay, so here we have CPM. Let's look at our midpoints. So if we use the midpoint of the rectangle, okay, so midpoint, let's see if I can write this. Whoa. Midpoint rectangles. So we have our area. We're still calculating the same area. We're approximating the area of F between 3 and 7. So use the approximate symbol. And now we don't want to start at 3 because we want to start at the midpoint between 3 and 3.5. So if our rectangle this is 3 and 3.5, the midpoint is going to be here at 3.25. The width of the base is still 1/2, so we could have our summation 1/2 times F, and now we're going to start at 3.25 as we just saw to get in the middle, plus, and each time we still want to add plus 1/2 I. Okay, so this is going to give us our base is 1/2 and our height, the midpoint height. So where do we start? Again, we want to start at I equals 0 and stop at 7. Okay, we plug in our calculator the same way as we did here, and we get approximately 6.563, and we just write units squared. Okay, so we already see that if we use left endpoints, we get 6.494. We use midpoint rectangles, we get 6.563. It's different. Okay, and it should be because we're approximating and the curve looks, the function isn't like a triangle or a line or anything like that. Anyway, so let's do it again for the right endpoints. So using right endpoints, let's make 8 rectangles. And now we can approximate our area. We still have our function between 3 and 7. And we know that's approximately. Now we want to use our summation. Okay, now this time we want to use the right endpoint. So the base is still going to be 1/2, but the height now is going to be starting at 3.5. We plug that into our function. So it's going to be 1/2 times our function at 3.5, right? Plus 1/2 I. Okay, and we're going to start at I equals to 0 to 7, and there you go. We plug that in our calculator using the same expression, our functions right here, but now we're going to change it to 3.5 plus 1/2, and we are going to get approximately 6.529, again, units squared. Okay, so we used our graphing calculator to enter our summation expressions and getting our approximate, that's a keyword area. We did it 3 times. You only needed to pick one way, but I did the left endpoint, the midpoint rectangles, and the right endpoint rectangles, using 8 rectangles each time. So this concludes number 40 in Chapter 2 of CPM Calculus.